Okay, problem number 7. So this problem is quite straightforward. So since, in my opinion, each exam should include the problem which everybody can solve. Okay, so let's see. So here we just need to calculate the area under the standard normal distribution curve, and we can easily do it by using normal standard distribution, and that's 1.1 cumulative, so it calculates the area to the left, and then we just need to subtract the area to the left from minus 0.05, so that's normal standard distribution minus 0.05 and also cumulative, and that's it. That's all you need to do for this problem. So something similar you should expect in the midterm exam. Okay, number 8. For a medical study, researcher wishes to select people in the middle of 60% of the population based on the blood pressure. If the mean pressure is 120 millimeters of mercury and the standard deviation is 8 millimeters of mercury, find the upper and lower readings that would qualify people to participate in this study. Okay, so here we have our empirical rule. We have what 68.27% of the data in between one standard deviation below and above the mean. Yeah, and we need 60%, so I just cut that area with the dashed line. So that's what we have. So 60%. So 60%. That's what we have in the middle. So that means we have 20% of the area to the left, and we have 20% of the area to the right. So that means we need to find such a z-score or such a pressure if you're not talking about a standard normal distribution and we talk about a normal distribution, so which cuts 80%, so 80% of the area to the left. And we also need to find such a z-score or such a pressure which cuts the 20% of the area to the left. Okay. We can find those z-scores and then recalculate z-scores to the pressure, because that's what we need. Yeah, we need like to calculate the pressure, the right boundary and the left boundary. Okay, so the right boundary is here, so this is the right boundary and this is the left boundary. So for the right boundary we can just use normal, and in this case we are not calculating the area, we are calculating vice versa. So we know the area and we want to calculate the z-score which cuts this area. So, and in this case we need to use normal inverted, and it is 0.8. So this is the right boundary, so 0.8. So that point right there, it cuts 0.8 of the area to the left. Okay, so the mean is given, so it is 120, and standard deviation is 8, and that's it. Okay, so this is 126.7 millimeters of mercury. And the left boundary we do the same, so that's normal inverted, and probability is 0.2. Yeah, so that's the left boundary, so which cuts 20% of the area to the left. Mean is 120 and standard deviation is 8, and that's it. So that's what we have for the left boundary. So that's it. So it means he needs to select people with the pressure in between 113.267 millimeters of mercury up to 126.733 millimeters of mercury. That's it. So something similar is going to be on the midterm exam. So you need like to understand how the normal distribution, normal standard distribution, and inverted functions work. Okay, now let's switch to the last problem. And here we have the average annual Canadian consumption of red meat, and it is 62.9 kilograms per person. Assume a standard deviation of 7 kilograms and approximately normal distribution. If a sample of 40 individuals is selected, find the probability that the mean of the sample will be less than 65 kilograms per year. Okay, we need to be careful here since we are estimating mean. So we estimated mean, that means we are applying central limit theorem, and in order to calculate the z-score we need to use this formula right here. Okay, so let's calculate the z-score. And it is equal to mean, so which mean of the sample, so x bar is the mean of the sample, so that's 65 minus mean of the population, so that's what we have here, 62.9, and divided by the standard deviation, which is 7, and divided by square root of n, which is the sample size, and it is equal to 40. Okay, so that's it. And our z-score is 1.897. Okay, and we need to calculate the probability that the mean is less than 65 kilograms per year. So the probability that the mean x bar is less than 65 kilograms and it is equal to, so that's normal standard distribution of our z-score, and it is cumulative because it is less than. So we can just apply cumulative option, and this is going to be our answer. Okay, that's it. So again, something similar to this problem is going to be on the midterm exam, so where you need to apply central limit theorem. Okay guys, so that's it. Exam is going to be 2 hours, and I'm given usually 10-15 minutes to submit your stuff to detail. If you are ready, so I think it will take you about an hour to solve everything. Okay, so that is why, in my opinion, so it's quite a straightforward exam. If you are ready, so if you are ready, guys. So if you go through this tutorial, I'm going to attach also empty file so you can follow this tutorial. If you do it, I think you will be ready and everything is going to be good. Okay, that's it. So that's it, and I think we covered everything you need to know for the midterm exam.